Alright, dear children, now we do next part, as I said already, that is Bohr's theory of hydrogen and hydrogen-like atoms. Bohr's theory of what? Hydrogen and hydrogen-like atom. That means Bohr's, who made the postulates, is basically applied for hydrogen and hydrogen-like atoms. Okay, and this is a theory which is not applicable for all the atoms. That's why I'll tell you one of the important part is Bohr's theory is not applicable for all the atoms of an element. That means there's some drawback or limitation even we can observe in Bohr's theory. Okay. Now hydrogen and hydrogen-like atom means hydrogen means a single atom. Okay. And hydrogen-like atom also means they are the atoms like lithium. Okay, which are the ionized arm. Okay, ionized form of the atoms. Okay, like lithium, helium ionized form of helium nucleus, ionized form of lithium, because He plus means in this helium nucleus, ionized form helium nucleus, and there's only one electron. Similarly, lithium Li plus plus means there's only one electron present in the Li plus plus atom. That means every hydrogen atom contains only one electron, which revolve around the what? Nucleus. So He plus means only one electron, also revolve around the what? Helium nucleus. Li plus plus means only one electron revolve around the what? Lithium nucleus. So such type of atoms are called hydrogen-like atoms. That means this theory, postulate and the theory proposed by Niels Bohr is applicable only for hydrogen and hydrogen-like atoms. Okay. So in his postulate, in his theory, we basically measure the radius of the different orbit, okay, in which the electron revolved, okay, and we calculate the speed of electron in the orbit. After that, we calculate the energy acquired by the electrons in different orbits, and with that energy, we calculate the frequency of the emitted radiation when electrons are from higher orbit to which orbit, lower orbits. So these are the quantity that we are going to measure in this theory proposed by Niels Bohr. So let's start with the expression of the radii of different orbits. So you know that in case of Bohr's theory, the electron revolve in different orbits, okay, but every orbit has a radius, and the radius of the different orbit can be measured with the help of Bohr's theory. Okay, so for that, let me just take the atom like hydrogen and hydrogen-like atom. So in this atom, this consists of the center part of the atom, and this center part of the atom I consider as nucleus, and this nucleus consists of charge. As you know, the charge of the nucleus is always positive, and we consider this as plus Ze. So every atom consists of nucleus, and nucleus is a positive charge, and the charge of the nucleus is plus Ze. And this nucleus can be the nucleus of hydrogen atom, it can be the nucleus of lithium atom, ionized atom, and it can be the nucleus of helium ionized atom also. Okay, now what happened? The electron revolve. So electron revolve in the different orbits. So let me make our orbit in which the electron revolves. Okay, so this is the electron orbit in which the electron is revolving. So this is the electron. So this is a what? Nucleus. This is our nucleus, and this is the what? Electron. This is a what? Electron. Now electron as a what charge? Negative charge, revolving in the orbit, in this particular orbit, and this orbit has a radius, and I consider that radius is what? R. But electron revolve in the orbit even with the velocity, and I just give by this arrowhead and represent by small letter b, and this small letter b is the velocity of electron at any position in this what? Orbit. Okay, so this is the structure of atom, and this is for hydrogen atom. It can be of hydrogen-like atom. This is for any atom. Okay, now hydrogen and hydrogen-like atom, as I said, consist of a tiny positively charged nucleus, and the electron revolve in the stable circular orbit around the what? Nucleus. Now every electron has charge, every electron has mass, and the electron revolve with a certain velocity. Okay, now see, every electron has a charge, as I said, and that charge of each electron is E. The symbol is E. Electron which revolve around the nucleus has a mass, and the mass is small letter m, move with the velocity with small letter b, and they move in an orbit, and that orbit has a radius, and that radius is what? Small letter what? R. But if you look at the diagram, this is the nucleus which consists of charge, positive charge, and that positive charge is plus Ze, And children, you know Z, this symbol of Z is called atomic number. Z is called what number? Atomic number. So what happened? As the electron revolves in the circular orbit, this electron is attracted by the nucleus with a force, and this force is called electrostatic force. But this electrostatic force at every position of the electron in the orbit is always attracted toward the center, and this force is also known as what? Centripetal force. Also known as what force? Centripetal force. So that means in this case the electrostatic force, static force is actually equals to what force? The centripetal force. Centripetal what? Force. So electrostatic force means the force of attraction between the nucleus and the electron, that is actually equals to the what force? Centripetal force. Now electrostatic force is actually measured by Coulomb's law, and you know Coulomb's law means, you have learned this, F equals to what? 1 by 4 pi epsilon naught Q1 Q2 by what? R square. So this is the formula you have learned according to Coulomb's law. Now this formula I am going to use for this electrostatic force. So electrostatic force between this positive charge and the negative charge of electron is measured by 1 by 4 pi epsilon naught into the charge of the nucleus. The charge of nucleus is Ze. The charge of electron is E divided by the radius is R. This radius is the distance between the positive charge and the electron, that is R square. So this is the electrostatic force, but that is equal to centripetal force. And you have learned centripetal force is always measured by the formula mb square by r. mb square by r, where m is the mass of the electron, b is the velocity of the electron, and r is the radius of the orbit. Okay, now from this relation only we can able to determine the radii of different orbits. Okay, now in the relation, let me just write this way, that mb square by r, I write this quantity left hand side, equals to 1 by 4 pi epsilon naught Z into E means ZE square by what? R. Okay, so in the relation, if you see this is R square, sorry. Okay, in the relation we can do the cancellation. Okay, and sorry, this is R only, sorry, this is R and this is R square. We can do the cancellation, and this R, 1 R and this 1 R cancel out. So it will be how much? mb square equals to 1 by 4 pi epsilon naught, okay, Z is square by R. So mb square equals to Z is square by 4 pi epsilon naught R. So this is the relation that we obtained from the two force exerted, the force which exert on the electron, that is electrostatic force, which is exactly equals to what force? Centripetal force. So let me give this as equation 1. Okay, but you know that electrons are revolving in the orbits. So when the electrons are revolving in the orbit, this electron also acquire what? Momentum. And what momentum the electron acquire? Angular momentum. So angular momentum of electron in any of the orbit is measured by which postulate? First postulate. Now I write on from what postulate? From Bohr's first postulate. From Bohr's first what? Postulates. Okay, we can write the angular momentum of the electron in any of the orbit, and that is given by mbr, and that angular momentum mbr equals to ns by what? 2 pi. Ns by what? 2 pi. So mbr equals to ns by what? 2 pi. Okay, so where n, as I said, n is 1 2 3 like this, actually indicate the number of orbit in which the electron revolve. Okay, so that the radius of the electron will revolve in the different orbit, the radius of the orbit in which the electron revolve can be measured for any of the orbit. Okay, so for that mbr equals to ns by what? 2 pi. Okay, so I just give this as equation number what? 2. So this is according to Bohr's first postulate. Now in order to measure the radius, okay, what I do squaring equation 2. I do squaring equation 2 both sides. And even I divide by equation 1 of that equation 2. Okay, so let me do the squaring of equation 2 both sides. So it will be how much? M square b square r square. Left hand side equals squaring means m square b square r square. Now I'll do squaring of this side. N become n square, h become h square by 2 pi square. If I do, it will be 4 2 square is 4 and pi square is pi square. Now after doing squaring, I'll do dividing equation 1 to this squaring side. So I divide this way, divide by the left hand side of equation 1, that is mb square, and I do the dividing of right hand side of equation 1, 1 by 4 pi epsilon naught, okay, z e square by what, r. So I did squaring of equation 2 first, then I divide by equation 1 of that squaring part, both sides. Now you can see there is some cancellation takes place, okay, and the cancellation will be m and 1 m square, m cancel out, okay, b square cancel out. So what is remaining in the left hand side? M r square. Now this will be reciprocal, so I write on n square h square, okay, by 4 pi square into, now this quantity will go up, means 4 pi epsilon naught along with r will go in the numerator, by z e square will remain in the denominator, okay. Now still we can see there is some cancellation takes place, okay. This r and 1 r square will cancel out both the sides, 4 and 4 cancel out, pi and 1 pi square will cancel out. That means we got the expression, that is mr equals to n square h square epsilon naught by pi z e square, okay. So after doing the cancellation on both the sides, so from here I'll make r as the subject. So if I make r as the subject, okay, let me just write this side, no problem. So it will be r equals to n square h square epsilon naught by, okay, pi, now this m will go in the denominator, so pi m z e square. So this is the expression of radius of the different orbit in which the electron revolve, okay. So r, that measure the radius of any of the orbit in which the electron revolve in an atom, and that r equals to n square h square epsilon naught, okay, by pi m z e square. So children, look at this expression of radius. So as I said, this is the radius expression of radii of the different orbit, any of the orbit acquired by the electron when they revolve in and around the nucleus, okay. But this expression say that for a given atom having atomic number same, h constant same, permittivity of free space also constant same, pi m z e, everything remain constant, this remain constant. So this quantity remain what? Constant for a given atom. So if this quantity remain constant, then we can write r is proportional to what? N square. That means the radius of any of the orbit is directly proportional to the what? The square of the what? The number of orbits in which the electron what? Revolved. Okay. That means this relation say that when we go to the higher orbit, means when the electron revolve in the higher orbit, they move with higher radius. That means the radius is directly proportional to n square. Okay. So with this relation, we can measure the radius in any of the radius of any of the orbit when the electron what? Revolve. Okay. But to measure the radius of any of the electron revolve in any of the orbit, we basically do now measure the radius of hydrogen atom. We do for what atom? Hydrogen atom. That means Bohr radius. Let me just write down Bohr's radius of what atom? Hydrogen atom. So children, we do basically for which atom? Hydrogen atom. Although the theory was proposed by Bohr for hydrogen and hydrogen-like atom, but we calculate Bohr radius, the radius of the first orbit of hydrogen atom. So for hydrogen atom means Z must be equals to 1, because atomic number of hydrogen is 1. Okay. Now for Bohr radius means n must be 1. Bohr radius means the radius of the first orbit, and that we take n equals to 1. So if I substitute Z equals to 1 and n equals to 1 in the relation, so we write down R also as R1. See, when n is 1, I write the same R as R1. So R1 equals to 1 square into h square epsilon naught by pi m. Now z means also 1 into e square, which means R1 equals to h square epsilon naught by pi m e square. Pi m what? E square. Now from this relation we can measure the what? Bohr radius, and that means this radius is actually called what radius? Bohr radius. Bohr's radius. So Bohr radius of hydrogen atom is given by R1, which is equal to h square epsilon naught by pi m e square. But in the expression on the right hand side, children, if you see, all quantity are known. H is Planck's constant, which is known. Epsilon naught is also known. Pi m is the mass of electron, that is also known, and E is the charge of electron, that is also what? Known. So if you substitute the value, and you know H value is usually 6.6 into the minus 34 joule second, that you learn in the chapter called photoelectric effect. Permittivity of free space, okay, that also you learn 8.85 into the minus 12. Okay, m by mass of the electron, that also known, and the mass of electron is always how much? 9.1 into the minus 31 what? Kg, 31 kg. Okay, and E is the charge of electron, that is also 1.6 into minus 19 coulomb. So if you substitute this value in the expression of R1, we measure the Bohr radius, and when you do the calculation and you measure the Bohr radius in Armstrong, so you get approximately 0.53 Armstrong. So I'm just writing directly the value of R1, but you can do the calculation by substituting this value in the relation, and you know pi value must be 3.14. Substitute pi equals 3.14 h epsilon naught m and e in the relation, and calculate radius in Armstrong. Okay, you measure nearly 0.53 Armstrong. So this 0.53 Armstrong is the what radius? Bohr radius of hydrogen atom. So this is for the first orbit of hydrogen atom. But the same sequence we can do to measure the radius of the second orbit of hydrogen atom. That means we can calculate the radius of any of the orbit with respect to the first orbit. But to calculate that, we just follow this relation. R is proportional to n square. Okay, so to calculate the radius of second orbit, the radius of second orbit will be 4 times the radius of what orbit? First orbit. Because n must be taken 2. 2 square means 4. So 4 times the radius of first orbit. So R2 will be the 4 times the radius of first orbit. Similar R3, if you calculate R3 means n will be 3. 3 square means 9. The 9 times the radius of what orbit? First orbit. So in this way we can calculate the radius of any of the higher orbit with respect to the first orbit. So from here I can say that the radius of second orbit is 4 times the radius of first orbit. Radius of third orbit is 9 times the radius of what orbit? First orbit. Similarly, if I go for fourth orbit, it will be 16 times the radius of first orbit. So it will go on and on. Okay, so from here I can say that the radius of the higher orbit is always calculated in the square of the number of orbit with respect to the first orbit. So this is the expression of radius of the different orbit in which the electron revolve in hydrogen and hydrogen-like atoms. Now in the next YouTube video, we measure the velocity of electrons, the energy acquired by the electrons.